Okay, so now we have seen the basic and formal definition and some basic understanding of supervised learning domain, and we have also some basic understanding of classification and regression. And we will have also two different sessions, two full-fledged sessions on classification as well as regression. So now move on to our second category, which is unsupervised learning domain, right? So the basic difference between the supervised learning domain and unsupervised learning domain is that in unsupervised learning domain, we have no desired output, right? So we have no associated labels with our training example. So this is the basic difference between a supervised learning algorithm and a unsupervised learning algorithm. In supervised learning algorithm, we have the training data set in which each instance have an associated label with it, but in unsupervised learning, we have no label associated with the training instance, or in simple words, I can say that in unsupervised learning, there is no desired output value, right? So we are basically trying to learn something about the data, right? So we don't know that what our training instance will be giving us as an output. So we are trying to learn it from the data itself, or we can say that we are trying to figure out the latent relationships between the entities present in the data set. So for example, I have photos and want to put them in 20 groups, right? So I don't know that which photo belongs to which category or which class, right? So I want to basically group or make a cluster of these different photos into multiple groups, maybe 20. So this is basically the target of an unsupervised learning domain. Another example can be that I want to find anomalies in the credit card usage patterns of my customers, right? So this can be another example which falls under unsupervised learning domain. So here is a visualization of the unsupervised learning domain, and we have it is useful for learning structure in the data, right? And this is what we are defining as the clustering. And so in clustering, we are basically forming clusters from the input data set, right? So again, we don't know the target class of the input data set, and our target under supervised learning domain is to form different clusters or groups based on some underlying properties or structures of the data, right? So our algorithm will be learning the underlying structure or pattern present in our data set, and on the basis of that underlying structure or pattern, it will basically form different clusters or groups of the data, right? And those underlying patterns can also be the correlations or hidden correlations between them. And most of the time we use these algorithms for reducing the dimension of our data set if it is a high dimensional data, right? Or maybe in sometimes where we use it to form clusters or groups. So we have a set of data here similar to supervised learning domain, but the difference is that now I don't know that which instance belongs to which class, right? So class of this instance is unknown. Similarly, the class of this instance is unknown, right? So on the basis of the underlying correlation or structure or pattern of these instances, I will basically try to make group or cluster of these input patterns or instances, right? So those instances which have similar attributes, similar characteristics, or similar structure, I will form one cluster out of them. And then some other instances which have similar attributes or characteristics, I will form another cluster out of them. And similarly, I can form another cluster out of them. And if I have some more data with some different related attributes, I can form another cluster out of them. So again, in unsupervised learning domain, I am interested in forming clusters or groups of different instances present in my data set, and those clusters will be based on some common or similar attributes or characteristics of my different training examples. But the major difference is that I don't have the desired output label or data class in the unsupervised learning domain. So here is another example about unsupervised learning domain. So now we know that under unsupervised learning domain, our training data set is unlabeled, right? We don't have any labeling associated with our training examples. So this is the basic and major difference. The system tries to learn without a teacher, right? So now since we don't have our desired output, so it means that there is no one teaching our algorithm about the output data. So the system is basically trying to learn itself from the data based on the characteristics and attributes. So we have a set of training data here, and that training data can have different individuals, and each individual can have its own attributes, properties, characteristics, right? And our unsupervised learning algorithm will try to figure out that which individuals have similar attributes or similar characteristics, and on the basis of those similar attributes it will basically form clusters or groups of them, as you can see in this figure. So in clustering, we are basically trying to detect group of similar visitors in your blog, right? If you have a blog and you have certain visitors, and we want to find out that which visitors have similar attributes or characteristics, then we can apply an unsupervised learning algorithm to perform clustering of different individuals, and those individuals will be clustered or they will be formed in a group and after this clustering algorithm. So this is the formal and basic definition of the unsupervised. So we are trying to form the clustering in unsupervised learning domain, and we are trying to detect group of similar visitors in the blog. And here you will notice in the previous example that our training data set has no label associated with them, right? Now, how will we be doing training in order to perform clustering? So in order to train the model or to train the algorithm, we just need to feed the training set to the clustering algorithm, right? So there are different clustering algorithms. When we will be discussing this topic, then I will explain and I will tell you that what different types of clustering algorithms are available. So whatever clustering algorithm we are using, we just need to feed the input training data set to our algorithm. And once we have that training data set, at no point we tell the algorithm which group a visitor belongs to, right? So during training, we are not telling our algorithm about the class or the desired target output label. So we are not basically giving this information in the unsupervised learning domain, and our algorithm will basically tries to find the groups without our help, and it will be doing this by determining the underlying relationships or characteristics of each individual. So another important thing in when we are trying to form clusters in unsupervised learning is the hierarchical clustering, right? So in hierarchical clustering, we are trying to bring similar elements together, or we are trying to bring similar objects together, and it will result in the form of a tree, which you can also see in this figure. So each node closer to each other are similar, right? So we are basically trying to form a hierarchy of all the objects, and we are trying to basically develop a tree in which each node has the objects which are similar to each other, and you can also see that in this figure.